Okay, today that we are going to take a look at analyzing um, uh, some transformations of a basic function and then something called a piecewise function. So first what we're going to do is take a look at a transformation of the absolute value graph plus 4, which what that's going to do is it is going to move the absolute value graph, that V-shaped graph, up 4. Okay, and so looking at that, let's determine the range. And remember, the range is bottom to top. So the graph does not exist until y equals 4 and continues to exist up from there. So the range, we should talk about domain too, but the range, bottom to top, would be y is greater than or equal to 4, or in interval notation, that would be 4 to infinity. The domain, from left to right, the graph doesn't have any breaks or discontinuities, and if we think about values that we can put in for x, we can put in anything, and so the domain we would say is all real numbers, or in interval notation, that would be negative infinity to infinity. Okay, let's take a look at a transformation of the square root curve. And so I'm going to answer some of these questions. So the square root of x minus 5 should be the square root curve, and it should be moved 5 units to the right. We're going to talk a little bit more about how I knew that, the transformations, later this unit. Okay, and so we have this graph over here. So the question is, first of all, on what interval, if anything, is the function increasing? And the function doesn't even exist until 5, and then it is increasing for the entire domain. So I am going to write that the function is increasing, and then I'm going to write which x values. And the x values would be from 5 to infinity. The next question is the function even, odd, or neither? Very clearly it looks neither. If I were to put f of negative x in, I'll just show what would happen. This would change the function to negative x minus 5. It didn't change the sign of the function, that would be out in front, and it did not go back to the original function. So that didn't equal f of x, and it didn't equal f of negative x. The third question, give the function's extrema, if any. Now, this function doesn't have dips on, like we see on some functions, but it does have a minimum because it does not start until here, okay, and then it goes up from there. So the function's extrema would be, it's 0, sorry, it occurs at 10, and it is 0. So this is a minimum, and it is actually an absolute minimum. It's the lowest point of the graph. Then last, how does the graph relate to one of the 12 basic functions? Well, it's related to the square root of x. And the square root of x, if I put that on here, starts at the origin. So this is the square root of x, and it is moved or shifted 5 units to the right. Okay, so the last thing we're going to do is we are going to take a look at piecewise functions. Piecewise functions, and I'm going to write here f of x equals, that didn't come through. Piecewise functions are functions that are formed by more than one function. And sometimes they can come in more than two pieces, but this piece is saying we're going to graph the square root of x when x is greater than or equal to 0. So that's when x is greater than or equal to 0, I'm just going to highlight for you. That means over here, that's where x is greater than or equal to 0 on the right side of the graph. So we're going to do the square root over here. And then we're going to do the sine of x when x is less than 0. And so when I'm graphing the sine of x, I'll make this pink, I guess. I am only going to graph sine of x on the left side of the graph when it's less than or equal to 0. Now, these graphs don't have to be perfect. They're going to be sketches, okay? And so I'll start with the top. I'm going to graph the square root of x when x is greater than or equal to 0. That's pretty easy because it doesn't normally even start till 0 and it goes this way. Okay. Then the sine curve, normally if I was sketching the sine curve, I'm just going to sketch here. This is how the sine curve would look. It goes through 0, 0. But I only want to graph it back when x is less than 0. So I'm going to start my graph here and I'm just going to kind of draw the sine curve, and again, doesn't have to be perfect, over on this side. Now, I made sure that at 0 this was closed circle, and then I made sure that this one said less than 0 so that we didn't have a dot on top of a dot. Okay. I'll talk about that in a second, maybe ones that don't meet. So this would be that piecewise function. Maybe let's do a piecewise function that doesn't meet at 0, 0 so you can see what I mean by that. So let's sketch a graph of, let's say, f of x equals, I'm trying to think of one. Let's do cosine of x when x is greater than or equal to 0. And then let's do x squared when x is less than 0. Okay. So I'm going to graph the cosine part of the curve only when x is positive. So if I was graphing the cosine curve normally, I would do on both sides. I'd make it even and just, oscillate that behavior. I only want it to exist when x is greater than or equal to 0. So at 0, the cosine goes through 1. Normally we'd sketch it then over here and over here. But I'm only going to sketch this portion of the graph because I only want when it is positive and it goes through the point 0, 1. I made a dot there because that's including 0, 0, 1. X squared is a parabola, and a parabola is U-shaped, but I only want to graph the parabola for when x is less than 0. So I'm not going to graph the part over here where it's positive. I'm only going to graph this part over here. Now, because it's saying x is less than 0, what I do is I leave an open circle at 0 just to show that that parabola goes right up to but does not include it. And what this does is this is not continuous, but it allows this still to be a function. Because if these circles, if this was closed and this was also closed, that would fail the vertical line test. But because this is closed and this is open, it is still a function, just not continuous.